Day 195 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 195 and we're still going strong, y'all. And guess what, y'all? Today we're doing our first hard problem, so I hope y'all are excited about that. We're in the middle of doing the top 150 interview LeetCode problems. We're going through them all. We're not going to miss any problems, and we've come across a hard problem, y'all. But don't worry. I think after all the progress we've made and all the knowledge that we have gained over these last 194 days, I think we'll be able to handle it. So I hope y'all are excited about that because today we're doing our first hard problem. But before we get started, y'all, if you need any AirPods, if you like Apple AirPods, you're into Apple AirPods, go ahead, check out the link in the description and go get you some from that link. And then after you do that, don't forget, bring a mouse right over here and click that subscribe button for me, y'all. And then after you click that subscribe button, go ahead and smash that like button for me, y'all. And then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we can run up this engagement and we could push this content out to a broader audience, y'all. As Swift community members, it's up to us to help the community to grow. And one way we can do that is to share this content out with as many people as we can find that will watch it. So your support is appreciated when it comes to that. Now, with all that being said, y'all, let's get started. And today we have question number 135, Candy. The difficulty level is hard, but don't worry, we're going to keep the solution as simple and easy to understand because we're all here on different levels of our programming journey and we want everybody to be able to walk away from this video having learned something. And in order to do that, we need to make sure everybody understands the solution. So we're going to keep the solution as easy and simple to understand as well so we all can walk away from this video having learned something. Now, let's see what the question says. The question says there are n children standing in a line. Each child is assigned a rating value given in the integer array ratings. You are giving candies to these children subjected to the following requirements. Each child must have at least one candy. Children with a higher rating get more candies than their neighbors. Return the minimum number of candies you need to distribute the candies to the children. So, let's break that down. That's a little confusing how it's worded, but let's look at these examples so we can make it make sense, right? In example 1, we have the input ratings equals an array of integers 1, 0, and 2. The output is 5. Explanation says you can allocate to the first, second, and third child with 2, 1, and 2 candies respectively, right? So if we give the first child 2 candies, second child 1 candy, third child 2 candies, in total we gave them 5 candies, right? So that's why the output is 5. But let's figure out why they gave the child the amount of candies that they gave them the child, right? So let's go through it. Let's look at this example right here. So this first child has a rating of 1, second child has a rating of 0, and the third child has a rating of 2. So this right here, this requirement says each child must have at least 1 candy. So that lets us know the child with the smallest rating should have 1 candy, right? So this child right here, let's just write it over here, right? So let's just start with them all having 1 candy, right? So we know this middle child is going to have 1 candy because it has the smallest rating. And now we look to the left, the child to the left, its neighbor, has has a rating of 1, which is higher than the middle child, which has a rating of 0. And it says right here, children with a higher rating get more candies than their neighbors. So since this first child has a rating of 1, we know, excuse me, y'all, we know he or she has to have more candies than this child that has a rating of 0. So since we could give it 3, 4, 5 candies, however many we want, but since we know we want to return the minimal number of candies, we know we want to keep the number of candies that we distribute as small or as minimal as possible. So if we give this child 1, we could give this child 2, right? So we just give this child 2 and that fits the requirements, right? For this child or for these 2 children, the requirements are still intact. This child has at least 1 candy, and this child now has 2 candies, which is because it has a higher rating. This child has a higher rating than the middle child, which means they get more candy, so we'll give them 2, right? Now we have to deal with the third child. Now the third child, you might say the third child has more candies than all the other 2 children, right? This one, and this one. However, so you would think maybe we should give the third child 3. However, since these two, the first child and the third child are not neighbors, we do not have to give the third child more than we gave the first child. We just had to give the third child more than we gave the second child, right? So with that information, we could give the third child 2 as well, and it will still fit the requirements, because the third child has now that the third child has 2, right? That's more than 1, which the second child has, because the third child has a higher rating. And the same thing with the first child. The first child has a higher rating than the second child, so we give him 2 candies, or her 2 candies as well. And now all the requirements are met. The first child gets 2 candies because it has more candies than its neighbor. It has a higher rating than its neighbor. Then his neighbor, the second child, gives 1 candy because it has the lowest rating out of everybody, but we know we have to give each child at least 1 candy. And then the third child, we could give 2 candies as well because the third child has a higher rating than the second child. And the second child has 1, so we could give the third child 2 as well. And since the third child and the first child are not neighbors, we could give them an equal amount of candies. And thus, the output for the candies, we get 2, 1, and 2. We add them all together, gives us 5. So let's look at example 2, where it's a little bit more tricky because there's 2 children that have an equal amount of candy and their neighbors, right? So in example 2, we have the input ratings equals an array of integers 1, 2, and 2. This time the output is 4. The explanation says you can allocate to the first, second, and third child with 1, 2, and 1 candies respectively. The third child gets 1 candy because it satisfies the above 2 conditions. So let's break that down again like we did last time. So first thing, we know the first child is going to get 1 candy because it has the smallest rating, and each child has to at least have 1 candy. So we give them 1 candy. We know the second child has to have more than the first child because they're neighbors and it has a higher rating, right? So since the second child has a higher rating, we have to give him more than the first child, but we want to still keep that number as minimal as possible, so we'll just give them 2 candies, right? Boom. Now this is where it gets tricky. The second and third child have equal ratings, right? So this requirement says children with a higher rating get more candies than their neighbors. But since these 2 children are neighbors and they have equal ratings, we do not have to give them more candies because it's equal. It's not greater than. If it was greater than, then we would have to give them more candies. But it's equal to. These are equal, so we don't have to give them more candies. And since we don't have to give them more candies, and it doesn't say we have to give them the same amount of candies, it just says we have to return the minimum number of candies. That means we could give them 1 candy. We don't have to. We can just give them 1 candy. We don't have to give them 3 candies or 2 candies because those are not in the conditions. The conditions say, right? The conditions say children with higher ratings get more candies than their neighbor. This does not have higher rating. These 2 children do not have higher ratings over each other. They have equal ratings, which means we do not have to give the third child more candies. We could just give them 1 candy because that's the minimal number that we could give them, right? So that's why the children would get 1, 2, and 1 candies, and the output would be 4 because this is not higher. This is equal to. So now that we understand the question, let's get into the fun part, the part that all keeps us going in the morning, the actual code, y'all. And don't worry, it's not that hard to understand. It's a little lengthy, but we'll get through it. First thing we're going to do, we're going to write a guard statement. We're going to say guard, exclamation point, ratings dot is empty, else we're just going to return 0. Then we're going to come down here. We are going to declare a variable called I. set that equal to 1, declare another one called count, set that equal to 1 as well. Then we're going to declare a variable called up. We're going to set that equal to 0. We're going to declare a variable called down. We're going to set that equal to 0. And we're going to declare a variable called peak. And we're going to set that equal to 0. Then we're going to say while parentheses I is less than ratings.count. We're going to come outside that. We're going to open up the brackets. We're going to say if ratings, open up the square brackets, I minus 1 is equal to ratings, square brackets I. What we're going to do, we're going to open up the brackets, regular brackets. We're going to increment up by 1. We're going to say up plus equals 1. Then we're going to say down equals 0. Then we're going to say peak equals up. Then if that doesn't work, we're going to say else if ratings, square brackets I minus 1 is equal to two equal signs, equal signs, ratings, square brackets I. What we're going to do, open up the brackets. We're going to say up equals 0, down, down equals 0, peak, y'all, peak equals 0 as well. Then we're going to increment count by saying count plus equals 1. Then if that fails, we're going to say else, open up the brackets. We're going to say down plus equals 1. Then we're going to say up equals 0. Then we're going to say count plus equals 1 plus down plus, open up the parentheses, peak greater than or equal to down, question mark. If that's true, then we're going to say -1, else we're going to say 0. Oh, not, excuse me, that shouldn't be a question mark right here. That should be a colon. Then we're going to come underneath that, and we are going to say I. We're just going to increment I. We're going to say I plus equals 1. We're going to come underneath that, and we're going to say return count. Now, that should be all she wrote, y'all. Let's see how it runs, because you never know. Wrong answer. Ooh, so where did we go wrong, y'all? Let's see, y'all. We went wrong somewhere. Don't worry, we'll find it. We will find it, y'all. Oh, right here. Excuse me, y'all. This should be count. Underneath the peak equals up, we should say count plus equals, plus y'all. Plus equals 1. Plus equals 1. Then we're going to say plus peak. Now, that should work. Let's run that. See if that works. Should work. Wrong answer again. So let's see where we went wrong this time. Let's clean that up. So let's see, y'all. Let's go through this, y'all. Where did we go wrong? Once again, we went wrong twice in the same. Oh, excuse me, y'all. This should be if ratings I minus 1 is less than ratings of I. So let's run this again. Yeah, this should not be the same. At first we had these two as the same. It shouldn't be the same. This first if should be less than. The second else if should be the equals. And that's accepted, y'all. So let's submit it. Make sure it stays accepted. Because you know how this LeetCode stuff and these pesky bugs could get. But look at that, y'all. 0 milliseconds beats 100% of users with Swift. That's what I like to see. That's faster than a Bugatti riding past Andrew Tate and the rest of the brokies on the highway, y'all. Make sure you wave at them as you riding past. Like, yeah, we riding past. We in our new Bugatti because we're Swift programmers. That's what we do. And that's it. Y'all. You know, I hope y'all learned something today. Get one more look at the code. My bad. I digress, y'all. Hold on. Get one more look at the code, though. Let's see. Look at it, read it, learn it, love it, live it, y'all. And I hope to see y'all tomorrow for another day, another LeetCode problem. See y'all then.